Good morning, afternoon and evening, everyone. Whether you are zooming in, then welcome to you all. Fraud is on the increase, and the systems that identify fraudulent activity need to become more and more sophisticated. Those systems need to be able to spot this type of transaction quickly and accurately. Machine learning and artificial intelligence are currently one of the hottest topics in technology today, and really can be used to help with the battle against fraud. Over the next 25 minutes, I will talk about how companies, in conjunction with H2O.ai technology, can increase the number of fraudulent activities that can be identified without compromising on the speed at which this is performed. Feel free to ask questions as we go along today. There's the Q&A window and the chat panel as well. I will try and pick these up as we go along, but please do remember, I'm a bloke. I have difficulty in multitasking, as I'm constantly reminded by both my wife and daughters. So, as Ivan said, my name's John Spooner. So let me quickly introduce myself to you in the form of numbers. How else would someone else introduce themselves who has a degree in applied statistics and been working in the industry for 23 years. Over the last couple of decades, I've worked with many organizations, whether it was large global financial organizations who want to automate their fraud decisioning, maybe telcos who want to speed up building cross-selling models, or major retailers who want to use millions of models to underpin their product recommendation strategy. Currently, I have the pleasure of being employed by the #1 open source software company in the world. We're specializing in artificial intelligence and machine learning, and we're H2O.ai. Basically, what we're doing through automation is allowing our customers to build hundreds, thousands, and millions of machine learning models and making data scientists efficient and valuable. So let's get on to the topic in hand, which is fraud. Fraud is the most commonly experienced crime currently in the UK. It currently costs the economy billions of pounds every single year, with criminals becoming more and more cunning in their attempts to steal customer, vendor, and government's money. And this really shows no sign whatsoever of changing. If we have a look at this particular graph, according to the Office of National Statistics, then there were an estimated 3.8 million instances of fraud in 2019 alone. This has grown over the last 2 years, regardless of it being consumer, retail, bank, or credit account fraud. So what is really driving this upturn? Well, if we think about how we're now living our day-to-day lives, clearly the increased use of online services by customers and businesses is really leading criminals to focus their efforts on defrauding people and these processes through online fraud and scams. Examples of this is seen by the huge growth in fraud being driven by online adverts and social media content. Fraudsters really are getting more sophisticated in the methods that they use. And we need to make sure that we are utilizing the latest advancements in technology and data to stay one step ahead of these criminals. Fraud, if we think about it, can result in the loss of both money, but also customer trust in a brand. But the detection and prevention is actually pretty difficult, because if we think about it, there's a huge amount of variety and volume of transactions that are taking place. But identifying fraud isn't new. Organizations are doing that, but after working with a number of companies over the last few years, I would pretty much say that there are a few fundamental issues in the current systems that are being used to identify fraud. The first one is a lot of these systems really only consider a handful of features or inputs or characteristics really call them what you want, but they only consider a handful of features about a person or a process to work out whether something is good or bad. Fraudsters are getting more sophisticated in their activity, and these simplistic summarizations that we have about accounts or transactions really don't allow us to pick out the most advanced fraud schemes or scams that are happening. Secondly, the features that are being used are really being put together in what I really call rule-based systems. And these rule-based systems are typically built up by humans. Many fraud systems are made up of thousands of rules. And while not bad with regards to delivering an acceptable level of accuracy, the management of these systems really can become unwieldy over time. What they're trying to do at the end of the day is look at what is normal behavior for maybe a customer or an account or an activity, and then and then compare that to criminal fraudulent activity. But the challenge that we have is that those behaviors are changing constantly, both normal and fraudulent behavior. So really trying to isolate new and different fraud patterns becomes really difficult if these rule-based systems are not updated regularly. But because they're rule-based, updating these manually can be incredibly time-consuming. Thirdly, if we're thinking about the current status, is the level of accuracy that these systems are providing. And there's always a possibility of improvement with regards to accuracy. If I think about organizations that I've spoken to recently, again, a lot of them suffer from identifying too many what are called false positives. False positives being the incorrect identification of an activity to be fraudulent when in fact it wasn't. The impact of this can be really twofold. Either it affects customer satisfaction in, say, a financial payment use case, if their customers feel that their card is being stopped too often, or alternatively, a business can be incurring a really large cost with regards to investigating those false positives, because they have to increase the number of manual checks that have to be made when suspicious activity is flagged by these particular systems. One of the great things about these rule-based systems that are in place, though, is that they are very easy to see how the systems are making decisions. Reason codes can be easily created. So fraudulent decisions, well, not fraudulent decisions, but decisions made about fraud can be explained to customers and regulators about really how the systems are thinking. And this builds an element of trust in the decision making. So any improvement that we are going to make in these systems really needs to make sure that any trust is maintained for further adoption to be taken. In certain situations, again, within maybe financial services, when we're looking at transaction monitoring, you only have a millisecond to make the right decision. And the speed at which that decision is made is really critical, because if you wait too long to make the most accurate decision, then probably it's too long and the fraud has already taken place and any loss or negative impact has already occurred. So while you were incredibly accurate, you weren't able to act quickly on the decision. And then finally, all of this has to be constantly updated. More and more digital activity is happening at a greater velocity. So these systems have to be updating themselves with as little human interaction as possible to allow us to stay one step ahead of the fraudsters. Striking the right balance across this, though, is incredibly difficult. Yes, it would be great to have the most accurate system with the most features, with the most trust, executing at the right speed. But it's really difficult to get that balance because a lot of the time, one impacts the other. So what do I mean by that? Well, add too many features into your fraud decision-making activity, and you could slow down the whole decision-making process. Move from a traditional rule-based approach to maybe something more complicated, then potentially you lose trust in that fraud decisioning system. Decrease the number of false positives that are having to be manually checked by a domain expert can put jobs at risk. However, applying certain principles in the whole area of artificial intelligence to this huge business challenge can really help strike a balance across all of these. So how do we do that? Well, the first area in which artificial intelligence can really help is, first of all, just really identifying the key features that help explain the behavior of an individual, a process, or a transaction. It's been proven through numerous amounts of research that basically the more data you have, both from a breadth perspective. So what I mean by that is more information about a transaction or a customer, but also more information that you have from a depth perspective. So basically, the more information that you have about the behavior that you're trying to identify, then the more accurate you're going to be in truly fully understanding behavior. And obviously think of that as the computer equivalent of gaining human experience. So the way that you can improve the predictive accuracy of your fraud systems is expanding the number of features that are being considered. And this is where current methodologies really break down, because trying to find out which bits of information is important can really take a long time to identify. And this is where machine learning can help accelerate this particular process. Clearly, with machine learning, what we're doing is trying to learn patterns in the data without being guided by a human analyst. So in this particular case, we can throw lots of features, like tens of hundreds of thousands of features about a particular activity, and the machine learning engine can work out what are the key bits of information that help us explain the behavior of something. So in this case, what are the key important pieces of information about a transaction, a person, a process that helps us identify whether any activity is fraudulent? And this is a really good first step in helping organizations improve their ability to identify fraud. So in this particular case, we're not building a specific model here. We're just trying to use machine learning algorithms to work out what are the best features. So in this slide, the engine has automatically worked out that age, location, payment method, and average spend are all good at working out the difference between transactions on fraudulent behavior. What you can then do is use these features and add them into existing rule-based systems, allowing the company to improve their identification rate. The next evolution that you've got with regards to improving fraud identification systems is really used to replacing those rule-based models to a machine learning algorithm to build that particular model. So in the same way that we looked before, we can use features about previous transactions that were both fraudulent and non-fraudulent. But what this technique is doing is generating some logic that will be able to predict which future transactions will be fraudulent. And the great thing about these particular approaches is that these models can replace the rules-based approach, and they can do that efficiently, and they can automatically then work out which transactions are most likely to be fraudulent moving forward. What we've seen, or what I've seen when working with companies, is that these models significantly reduce the number of false positives that traditional systems generate. So as organized crime activity does become more sophisticated, then just having one single algorithm or one size fits all analytical technique won't produce an optimal result. What we need to be doing is quickly building supervised models. So basically a supervised model is something or is a model that is built on labeled or tagged transactions that are either fraudulent or non-fraudulent, and then using a methodology to build that machine learning model. But this area of building models is a fast changing field itself. And this isn't new. Organizations have been embarking on this journey, but what they have found in recent times is that the process of building these machine learning models can be incredibly time consuming. Teams that build these machine learning models tend to adjust these models manually. So they take weeks to build and update. And what has happened is that a new discipline has emerged, and that new discipline that has emerged is something called auto ML. Auto ML is about automating a lot of the manual process that goes on behind the scenes of building these specific machine learning models. And H2O.ai is at the leading edge of this particular discipline. In fact, we've produced a product specifically that helps with regards to this, a product called Driverless AI. And Driverless AI can be used as a solution for fraud identification, because what it helps people do is to build these machine learning models, work out what are the key features that helps identify fraud, and do that incredibly quickly. And what I'm going to do is actually show you Driverless AI, but I'm going to do that on a specific data table. So this is just a quick summary of that particular data table. So we've got something like 6 million transactions, and we've got information about each individual transaction. And we've got a column, something called is fraud, that flags whether that transaction was reported as fraudulent. We've got a column called is flagged fraud, which was the existing system that has been used to flag the fraud. And then we've got information about the transaction itself, where what the type of transaction was, the amount in currency, and then information about where money was going from and to. So with Driverless AI, you can basically have a look at your data. So here is my data table. So we can see here are those columns that I talked about. And what I'm interested in doing is, first of all, working out what features are important to distinguish between fraud and non-fraud. So what I'm able to do is to create what is referred to as an experiment. And what an experiment allows me to do is to set the system to run machine learning to work out not only the key features, but also the underlying model. What I have to do is to select the column that I'm interested in predicting. I need to drop this is flagged fraud, because the is flagged fraud is an output from the existing system, and I don't want to use that in my modeling. And then I've got various different dials that allow me to turn up and turn down the accuracy, the time, or the interpretability of the output that I get. So not only is this a tool that can be used just using a very simple interface with these particular dials, but some of you may be from a data science background that would want to have a little bit more control over how that machine learning model was built. So what we're able to do is to go into particular areas and tweak those options. So I can just turn certain things on and off, save those, and then I can launch the experiment. So while that's just starting off, let me just have a look at a few of the questions that are coming in. So one of the questions that I can see here from Mazood is often data sets for fraud models are imbalanced, so very few instances of fraud. So how does your system cope with this? And that's a really, really good question, because you're right. The one challenge that you have with fraud models is that you don't have a huge number of transactions that are flagged as fraud. So the system itself automatically takes into account that we have to extract the most information out from those fraudulent transactions. So behind the scenes, we've got the engine is automatically doing some what's called oversampling that is allowing us to put more weight on the fraudulent customers or transactions, and then comparing those with the non-fraudulent transactions. So as you can see, we're currently running this particular experiment. We've got various metrics that are being shown. So once that model has been built, we would have then something called precision and recall and lift then available to us. So while that's just running behind the scenes, what we can see in this particular window is where we've already run some experiments. And what we can quickly see is some experiments have got some very high scores associated to a goodness of fit metric that we're using. And if I go into a particular experiment that's run, what I can start to do is to see how that engine has generated a particular result. One of the key benefits of driverless AI is its ability to create new features from existing data. So if I look down here, we can see that we start with driverless AI. In this particular experiment, we considered over 1,000 manipulations of the features that we had. And that was based on a starting number of only 11. So what we're really trying to do here is to squeeze the extra juice out of the data. A lot of work has been done over the last 4 or 5 years with regards to the algorithms that are running behind the scenes with regards to machine learning. I really am a true believer in the big performance gain that you get now from identifying fraud isn't from the algorithm that is being executed, but it's by how do you manipulate the features that you have to then go into that particular algorithm. And this is a great example how to try and create manually 1,000 features would potentially take someone days or weeks to do. Within driverless AI, it's a matter of minutes that allow you to then do that. So that's just a really quick example how driverless can take some existing data and build a highly accurate machine learning model behind the scenes. But, and this really links into the next question that I'm seeing in the chat from Martin is, well, how do you handle explainability requirements of the machine learning models? And this is a really, really good point. So as organizations make that move to machine learning models to really drive out their fraud identification efforts, they really need to make sure that trust or explainability, as Martin talks about, is maintained in these new systems. Currently, people trust these rule-based systems that they already have. They know how those work because at the end of the day, it's just if then else logic. While it is accepted that those systems will produce a high number of false positives, there is a sacrifice that companies have been willing to make. And that sacrifice is that high number of false positives. The problem that organizations now are having, though, is the cost of dealing with those number of false positives is just too great, which is why that switch to a machine learning model is critical. But that machine learning model, just by its very nature, is incredibly complicated. What you're seeing here is a diagram of a neural network, which just by itself is incredibly complicated, of which some people see that as a black box. And if you're building up a system that you really don't know how predictions are being made, that really can be problematic to regulators, internal stakeholders, and also customers. So the key is we need to make sure that we are making the models as accurate as possible, but also making them transparent. So you can make these models transparent. And there's been a huge amount of research done over the last, I would say, 18 months to 2 years around how do you make these models more and more explainable. I would definitely check out some of the work H2O.ai has done around responsible AI. Feel free to go to our website. All I'm going to do in this particular presentation is really touch on this topic really, really lightly and say that at a high level, you can really work out how machine learning model is making its decision. The first thing that you have to get is you need to know overall, how is that machine learning model making its decision? And that is a concept called a global interpretation. And it's about knowing what are the key characteristics, features that are really driving or differentiating between fraud and non-fraud. Why is this important? Well, it's important, as we've talked about, to justify to internal stakeholders, etc. But it's also important to make sure that any protected characteristics about a customer, so things such as gender, race, sexual orientation, or even maybe proxy features now that are being created as part of that model building process that mimic these, making sure that they're not being used in the model to be giving sort of unfair or discriminatory treatment to certain individuals. So that is global interpretation. But then you also want to know, what is it about a specific individual transaction that caused it to be flagged as fraudulent? So was it where the transaction was taking place? Was it the amount? Was it a combination of the two? And that's what we call local interpretation. And driverless AI can generate this level of interpretability for all machine learning models that have been created. Machine learning models that have been built by driverless AI, but also machine learning models that have been built by third-party tools as well. So we have within driverless AI this concept called machine learning interpretability, and we can look at lots of different ways of summarizing that model from an interpretability perspective. Again, this particular topic in itself just warrants a whole webinar. So if you do want to know more about this, then put that in your feedback, and we can definitely run another session that looks at going into this in specific detail. But we can see here that for this particular model, we can quickly see what are the key features that are driving whether or not a transaction is fraudulent. There's a number of different methodologies, and we also have this methodology called disparate impact analysis. And disparate impact analysis allows us to see, are there protected characteristics such as gender and age, and start to see, do we have differences across the groups of those particular characteristics. Shapley is a commonly used method to look at features that are important, and this is where we can also drill down into specific rows to really see how is a feature different across a particular row. So what we've done there is built a machine learning model, but that's just half of the challenge complete. The next half is what we need to do is to put that model into an environment that it's making decisions about transactions in real time. So once these fraud machine learning models have been built, they need to be put into production. And again, there's a whole discipline around this. It's referred to as model ops, or sometimes called ML ops. But whatever it's called, it's really made up of three key components. The first component is about how do you take that model and put it into production. So it's the process of moving that model out of that development environment and running it on a production infrastructure. This is really, really important for fraud detection systems, as you need to make sure that predictions are being delivered at a really, really low latency because of the nature of what we're trying to identify, but also through a very, very high throughput. The second area is that of model lifecycle management. So here, what you need is an automated process to make sure that you're evaluating your model when it's in production. So to make sure that your model is performing as expected, to troubleshoot any production issues, and then automatically, if possible, update those models as needed. And this is really critical in fraud detection systems. As we've said, or as I said throughout this presentation, fraud is changing constantly. Customers' behavior is changing constantly. So these processes and these models need to be constantly learning really what I call the previously unknown, and doing that in an automated process to make sure that those accuracy levels are maintained. So the final bit around putting these models into production is that around model governance. And this is where you've got controls in place to ensure that the models that you've got are safe, they're not going to break, and you have all the information that you have for any legal or regulatory issue that could crop up. So within Driverless AI, we have this concept of a mojo, and just through a click of a button, we can create a mojo, which is a model which can be deployed into any system that is being executed. One important thing that I just wanted to point out within Driverless AI here is, as we increase the complexity of the model, we talked about the speed at which that model is going to be executed in a production system could be affected. What driverless AI gives you straight out of the box is an indication, so I've just highlighted it here, of the mojo latency. So if this model was to be deployed into a production system, then this model would only take 0.071 milliseconds to run and give a prediction of how likely is a customer or a transaction to default on a particular, sorry, not default, but make a fraudulent transaction. What H2O also offer is software that helps with that whole MLOps life cycle that I previously talked about. So if you want to put these models into a particular framework that allows your IT to move from these models from a development environment into production and have automated ways of monitoring these models, then LMOps is software that you may well be interested in. So I've talked about these fraud systems, but let's take a case study and really show where a customer of H2O has really gained value from machine learning. So PayPal is a great example of an organization at the forefront of their industry that has used our technology to really take their fraud decisioning to the next level. If we look at PayPal in itself, it's a huge entity. It's got what, 218 million active account holders across hundreds of different markets, across 25 or so currencies. They've been doing fraud detection for many, many years, but they were always looking to improve their fraud detection rate. What they were also finding was their systems were becoming more and more sophisticated, but the time that it was taking for those systems to run just wasn't fast enough, but also the time that it was taking to update those systems, again, wasn't good enough. They worked with us and the Driverless AI software, and where they saw a real big benefit was they saw the accuracy of their models increase by over 6%. So they moved the dial from 89% to 95%, and really saw their number of false positives reduce dramatically. In this particular use case, it was actually the thing that drove the accuracy of the models. So as I've said previously, it wasn't the algorithm itself. It was the features that were automatically generated on the existing data that really drove that accuracy level. What they saw as well is their model development times were actually reduced by a factor of 6. So they will be able to churn out their data scientists when then a lot more efficient. One thing that I didn't show within the very quick highlight of Driverless AI, but is one of the benefits of the technology, is that it automatically generates documentation of the model building process. And that was really valuable to PayPal because they were able to automatically create all of the paperwork that was needed to get the new model approved by the regulators. So, in summary, really what hopefully you've seen over the last 40 minutes is machine learning can be applied to improve fraud identification both quickly and accurately. As enterprises look to modernize their existing systems, what we've seen is that they can really reduce the time that it takes to identify these key features that be used to identify fraud. We can increase the accuracy of these fraud systems and reduce the number of false positives. And we can also start to automate all parts of this process through both AutoML, but also through MLOps as well. And also then finally, we can make sure that we're maintaining trust in these systems by utilizing interpretability as well. So just finally, we here at H2O.ai can help both from a machine learning technology perspective, its challenges, and we have the tools and experts to really help you succeed. If you do want to get hands-on experience with driverless AI, then do feel free to take advantage of our 21-day free trial. Information is on the screen here. And that's all that I want to cover. So over to you. Let me just go back to the questions and answers. So let me have a look at some of the questions here. One question that's coming in is, how often do the models need to be retrained? Well, Steve, that's a really, really good question. What I always say is models are a little bit like fish. They go off. The problem that you have is you don't know when they're going to go off, which is why that you need to have a model monitoring system in place to check to see how are those models performing over time and start to create alerts that allow you to spot one of two things. Is there a change in the scores that are being generated from the model? Because if there's an overall shift in the distribution of scores, then that's probably indicating there's something going on behind the scenes that is allowing your models to be retrained, or need your models to be retrained. Also, you may want to be looking at the general patterns of your inputs over time as well. So maybe the distribution of age is changing with regards to your customer base. And again, if your distribution changes above a particular threshold, that will give you enough evidence to then retrain the models. So the answer to that particular question is it really depends. It depends on how quickly is the data changing to then drive that new model that needs to be put into production.
Great, thanks, John. I also see a lot of questions coming in. So maybe can you elaborate on the algorithm used and when would you be using supervised and unsupervised learning models?
Sure, yeah, sure. So driverless AI is a supervised learning technique. So it will automatically be using that particular methodology. In terms of the algorithms that are being run behind the scenes, then it's a whole plethora of different algorithms that are being run to work out for this particular data, what is the best algorithm, and also hyperparameterization, a long word there, but basically it just means the overall structure of the algorithm that is being executed. But there's a whole plethora of hyperparameters and algorithms being run, ranging from simple statistical models like GLMs, all the way through to nonlinear methodologies such as decision trees, looking at algorithms such as gradient boosting models. And it's also running neural network models behind the scenes as well. In fact, driverless AI has got an open architecture, and driverless AI allows you to create your own, what are referred to as custom recipes. So if there's a specific algorithm that you want to run, and that algorithm is available as part of a open source package, then you can write a custom recipe to access that open source package and execute that algorithm against the data that you have within Driverless AI and see what impact that has with regards to its performance.
Thank you, John. Another question that came in. So if a company doesn't want to send data that can identify customers, is it still possible to make a good fraud prediction with a limited number of features?
So it will be the challenge, but it just wouldn't be as good, because the advantage that you get if you're able to know, even at a high level, what is the customer that has done the transaction, and you don't have to identify them in terms of name or address, they can just be a number. But if you're able to work out, well, what is normal behavior for that customer, then the system has got a much higher chance of working out what is unusual behavior for that customer than if it had no information whatsoever about that particular customer. But there are ways of anonymizing the data. So while you can still build up a customer history, you actually can't personally identify who that customer is.
Great, thanks. I'm just looking at all the questions.
Yeah, so one question that I've got here is, one person asked, why has your data science team got lots of Kaggle grandmasters? Is there any relationship with Kaggle, the company? Well, and that's a really, really good question. So those of you that don't know, Kaggle is a sort of gaming platform for data scientists. So organizations can put data tables on there and set competitions to solve particular problems, and data scientists compete against each other to solve those data science challenges. And participants are awarded points, and the more points you accumulate, the higher up the leaderboard you go. And those people that are top of the leaderboards on a consistent basis are ranked as Kaggle grandmasters. And there's about 135 of them in the world. And H2O employ over about 10% of them. And the reason that we have so many Kaggle grandmasters on our team is that they are able to really be at the cutting edge of data science, and they are able to work with our customers on helping our customers solve the hardest problems. And because they're the best of the best with regards to data science, they really add benefit in helping our customers solve those really, really hard problems. What they're also doing is taking a lot of their tips and tricks that they use to win these particular competitions and embedding that into H2O's product portfolio, allowing you as a customer of H2O to benefit from that through their knowledge in the software.
Thanks, John. So how reliable, flexible, and customizable is Driverless AI?
So in terms of reliable, it's incredibly reliable and also scalable as well. So it runs across both a cloud environment, whether that be Azure or AWS or Google Cloud Platform, or it can run on-premise, and it can run across multiple machines within those environments. And it can also utilize both CPUs and GPUs of those compute environments. So it's highly scalable, so we can bring in millions of rows of data and thousands of different features and really build the most accurate model possible given the data that you've got. In terms of flexibility, then it's incredibly flexible. As I showed within the quick demonstration, there's a number of different expert settings that a data scientist can then control. In fact, there's probably over 1,000 different configuration options that a data scientist can modify if they so wish. And then, as I talked about before, it sits on top of an open architecture. So data scientists can bring in their own custom recipes, to bring in their own algorithms, but it can also be used to create custom scorers as well. So what driverless AI is trying to do is to fit the best model given the data, but that definition of best and how the model is optimized can differ between organizations. You may want to optimize on something very unique to your organization, and you can create your own custom scorers and use those to really drive the optimization of driverless AI. So that's the reliability. You've got the flexibility, and what was the third one, Ivan?
Customizable. So
And how customized it is. Yeah,
exactly.
it's fully customizable.
Could you elaborate on the rationality underlying the feature generation which you demonstrated, and why the same level of feature engineering would take a data science team weeks?
Yeah, so, and this is a really good question. So if we think about feature, so if we took the example that we had in the demonstration, we only had 11 features. But there's lots of different modifications that we could make on those particular features. So, but the more modifications we make, the number of features that we would have to explore increases exponentially. So even if I just wanted to look at the interaction terms between all of those features, the number of features that I'm having to consider is going up incredibly quickly. And the key is that you actually don't want to go through a brute force approach. So you don't want to manually create every single combination of features to work out which are the most important. You want an automated method to do that. So that's what driverless AI is doing, which is very different from other AutoML providers that really go through a brute force approach. So what driverless AI does is utilizes a genetic algorithm behind the scenes. And what it does is starts off with its raw features. First of all, works out which of those raw features are important at predicting the behavior that you're trying to model. And then it does some modification of those most important features, but then puts in a random transformation of the other features to see, actually, by manipulating the new some of the weaker features, do we increase the performance of the model? And that genetic algorithm iterates through. So those stronger features are being manipulated more, and those weaker features are being manipulated less. And what that allows you to get to is the number of important features a lot more quickly than if you went through that manual process. Because if we think about that manual process, you're having to work out, based on the original features, what are the features we should consider. And if you've got 11 features, you probably would look at, I don't know, you would manually create maybe 300 or 400. We saw that driverless AI, in a matter of minutes, created thousands of features. That it becomes even more problematic if you start off with hundreds of features. The number of different combinations that you would have to make from a mathematical perspective increases exponentially, which is just impossible to do for a human to do.
Great, thanks, John. I think we have time for 1 or 2 more questions. So what are the false positive rates in case of the rule-based approach and the model-based approach?
Okay, so with regards to that particular question, then it is all dependent on the data that you have. So what you will know already is what your false positive rate is for your existing rule-based model. What you're able to do within driverless AI, so in this, but I've just gone back to driverless AI just to show this concept more. What we can see is, well, in this particular case, in the bottom right-hand corner, we can see what's referred to as our confusion matrix. So that leading diagonal, so the numbers in the yellow is indicating the predictions that were made correctly. So 1 is actually fraud, 0 is non-fraud. But we can also start to see our false positives and the number of false positives in this particular training set. So that allows us to go back to our existing rules-based methodology and see whether or not this machine learning approach has outperformed our existing model.
Great, thanks. Okay. So we received a lot of questions. We couldn't answer all of them today, but we will make sure to collect all the questions and come up with a Q&A document with our answers. Thank you, John, for taking the time today, and thank you to everyone who joined us. We hope you enjoyed the presentation. Stay tuned for upcoming events and have a great rest of the day. Thank you, John. Bye.
Thank you. Thank you all for attending. Take care. Bye.